Welcome to the Future of Life Institute podcast. My name is Gus Duggar. On this episode, I talk with Alan Robock. Alan is an atmospheric scientist at Rutgers University, and he was a member of the Intergovernmental Panel on Climate Change when it was awarded the Nobel Peace Prize in 2007. So on this episode, we discuss the science of nuclear winter, we discuss which places might be targeted in a nuclear war, how international collaboration would collapse during a nuclear winter. And then we also discuss whether it's wise to prepare for nuclear winter by researching geoengineering or food production without sunlight. Here's Alan Robock. You have been researching nuclear winter for a number of decades now. Could you tell us what is nuclear winter?
Nuclear winter is the climate change that would result from a nuclear war. In a nuclear war, cities and industrial areas would be targeted and they would burn, producing lots of smoke, which would go up into the atmosphere and rise into the layer we call the stratosphere, which is above the layer where we live. And so there's no rain there to wash it out, and it would last for years. That would absorb sunlight, and it would get cold and dark and dry at the Earth's surface. And if there was enough smoke, temperatures could get below freezing even in the summertime. And that's why we call it nuclear winter.
And this work is mostly built on computer simulations, if I understand it correctly. Is that true?
Well, yeah, we can't actually do the experiment in the real world. If we did,
Yes.
it would be too late. So we use computer models that have been tested with other things like volcanic eruptions and forest fires. And then we use natural analogs to test parts of the theory.
What information do we gain from these volcanic eruptions and forest fires?
Volcanic eruptions every once in a while produce clouds in the stratosphere too, and they reflect sunlight and make it colder at the Earth's surface. After large eruptions, there have been significant coolings. In 1815, the Tambora eruption in Indonesia produced a cloud that went around the world, and in 1816, it produced a year without a summer. It was There was snow every month in the summer in New England in the United States. And so this cooling, which lasted about a year, caused famine in the United States, in Europe, and in China. So this is a natural example of what we think would happen to even greater extent after nuclear war.
These volcanic eruptions, they are kind of natural equivalents to what would happen in the case of a nuclear war causing a nuclear winter. So the greatest harm would come from agricultural collapse. Is that correct?
Yeah, well, if nuclear weapons were used, the direct effects would be horrific, of course. We know what would happen uh, because of the examples during the first nuclear war 77 years ago when the US attacked Hiroshima and Nagasaki. There would be blasts, there would be fires, and there would be radioactivity. And that would be horrible. But we've calculated that more than 10 times as many people would die in areas far removed from the attack than from the direct effects. Calculating the probability of a nuclear war is above my pay grade. I don't know how to do that. We don't have any data. There's been one nuclear war in the history of the world, and there haven't been any for more than 75 years now. So the question is, what could actually start another nuclear war? The first thing is the existence of nuclear weapons means that they can be used. So if we get rid of nuclear weapons, then we can't have a nuclear war. And that's the ultimate solution because they really can't be used in any logical way. They could be used by accident, by misreading of sensors. There have been several cases where countries thought they were under attack and they almost launched a nuclear war where it was either a computer malfunction or a human error. The US Secretary of Defense was woken up in the middle of the night once from people in Colorado saying, "We're under attack, wake up the president." And it turned out they'd put a training tape in rather than the actual one, and they thought it was a real attack. The Russians thought that they were being attacked when Norway launched a sounding rocket, and it was from the direction of the United States. Norway had informed the Russians they were going to do that, but the communication got lost and they thought they were under attack. Another time, a Russian system thought 5 missiles were on the way. And the officer in charge, Stanislav Petrov, said, I built that system. That looks kind of funny. I know my orders are to warn the hierarchy to start a war, but if they attacked, why would it only be 5 missiles? And it turned out it was reflection off of clouds that they were sensing. So there are all kinds of scenarios that we know about, and I'm sure there are a lot that we don't know about that could have almost started a nuclear war. There are now 9 nations with nuclear weapons. There was just one, the United States, and then Soviet Union, and then England, France, and China. Those are called the P5, the permanent members of the Security Council. And now 4 more nations have nuclear weapons: India, Pakistan, North Korea, and Israel, although Israel won't admit it. So about 15, 17 years ago, we started thinking about, well, some of these new nations, they don't have that many weapons, but what if they had a nuclear war? What would that do to the climate? And so we calculated the effects of an India-Pakistan nuclear war, because at the time, due to their continuing skirmishes along the Kashmiri border, some of which actually ended up in fighting, we thought that might be the most likely way that a nuclear war could start.
And India and Pakistan, compared to the US and Russia, they don't have a lot of nuclear weapons, but still the effects from a nuclear war between them could be horrific. So could you tell us about the simulation of a nuclear war between India and Pakistan?
When we started doing this work, again, looking at India, Pakistan, each country had about 100 nuclear weapons. And the easiest ones to make are a uranium bomb like the US dropped on Hiroshima. Just 2 pieces of uranium get put together, and that makes a critical mass and it explodes. It doesn't require a lot of high technology. And the explosive power of that bomb was about 15 kilotons, equivalent of 15,000 tons of TNT. So we assumed that these were the size that they had, and the scenario we used was each of them used half of their nuclear weapons to attack the other country. So 100 Hiroshima-sized nuclear weapons. And then we calculated how much smoke would be generated by cities burning in each country, and we got more than 6 million tons of smoke. To simplify it, I just calculated 5 million tons of smoke. So really that would be only like 85 weapons. And so my student Luke Oman was studying volcanic eruptions, and we had computer model to do that, and we put that much smoke in and calculated the climate response. And we were surprised it wouldn't produce nuclear winter, that is, temperatures wouldn't get below freezing in the summertime, but it would cool the Earth to temperatures colder than the Little Ice Age. In fact, it would be climate change greater than ever before experienced in recorded human history.
This smoke we're talking about, what type of smoke is this?
Well, we just use black carbon, soot, pure black carbon. And in the real world, when you burn something, if you can smell smoke, then that's not the carbon, that's the unburnt organic material that sometimes can coat the smoke. And so we're in the process now of trying to do a more realistic calculation of exactly what the chemistry of the smoke would be and how it would be affected as it goes up into the stratosphere. Another another analog we use is large forest fires. So in our model, the smoke goes into the lower stratosphere. The sunlight hits it. It's black, so it absorbs sunlight and gets heated. And then it rises farther up into the atmosphere to the upper stratosphere. And that's what makes it last for years and blow around the world.
But we
Uh,
have reason to believe that in an actual nuclear war, cities would be attacked. And so we would actually get the bad kind of smoke from the burning of the urban and industrial areas.
that's right. The military claims that they only target military targets. They claim we don't target civilians per se. In fact, the law of war prohibits it, although I'm not sure if there's anybody available to enforce that law. And certainly after nuclear war, there wouldn't be. But it turns out that there are a lot of military targets in cities. In the US, there's this funny 5-sided building in Washington, D.C. I think I remember that there were over 100 targets in Moscow that the U.S. considers military targets. I had the surreal experience of meeting Fidel Castro twice, who invited me down to Cuba to talk about nuclear winter. And he explained that during the Cuban Missile Crisis, they took when the U.S. was going to potentially attack, they distributed their airplanes to lots of different regional airports around the country so they couldn't all be hit in one place because they had the example of that happening in other wars. So there would be, the US and Russia each have thousands of nuclear weapons, and we can't find that many targets in each country. So in the 1980s, when we calculated nuclear winter, when their arsenals were much bigger, we put, we only used a third of each arsenal, and we put one weapon on every possible target in each country. And then there was still this huge pile of weapons. Well, all right, let's put two on in case the first one doesn't work. And there was still a huge pile. It turns out there were 9 weapons for every target.
That is an astonishing fact. Why, why did the U.S. and Russia build so many nuclear weapons? That's a question that I've often wondered. What's the strategic importance of having thousands upon thousands of nuclear warheads?
And why do they still have that many? All the other countries with nuclear weapons have a couple hundred. The US and Russia still have thousands. Well, I don't think it makes any military sense. In fact, we have a triad. We have land-based missiles, we have bombs that go onto airplanes, and we have submarine-based ballistic missiles. And why do we need all of those? In fact, the land-based missiles are very destabilizing because the Russians know where they are. If they're being attacked, they have to be launched within a few tens of minutes or they'll be destroyed. And so the president has to make a decision very quickly. And what if they aren't really being attacked? What if it's a false alarm? Are they going to be starting a nuclear war? And so one of the quickest things we could do to make the world safer is to take those off of a hair trigger alert and then get rid of them. We don't need them. We can't use them. In fact, if we ever think using nuclear weapons is a good idea, we can use the invulnerable submarine-based missiles, and we don't have to do it really quickly. I think it comes down to money and power. That's why we have so many. There are huge huge corporations that make lots of money building nuclear weapons. There are military people whose careers are based on controlling these nuclear weapons, and they don't want to give that up. In fact, when the New START Treaty was signed 10 years ago by President Obama and President Medvedev, to get it approved by the U.S. Senate, which requires a 2/3 vote, Obama promised them a modernization of our nuclear arsenal. And unfortunately, that's still going on. So the U.S. is planning to spend more than $1 trillion to build new missiles to replace the ones that we already have that still work, new submarines, new airplanes, and they can't be used. So it's a huge sink of money that could be used for much more useful things, like giving, for example, vaccines to everybody in the world or healthcare. So I think it's and they make so much money. They have armies of lobbyists going into to give money to congressmen and to use fear as a weapon. People think if we have more weapons than they do, or they have more weapons than we do, that's a problem. And so, but that's not always what's happened in history. When the Soviet Union was falling apart, in fact, when President Obama was president, I was at an American Geophysical Union meeting, and his nuclear advisor, Rose Gottmuller, was there talking about detection of underground tests. And after her talk, I went up to her and said, why doesn't President Obama reduce our nuclear arsenal? We have way more than we need. We can't use them. We don't need a treaty to reduce them. Oh, no, we can't do that. And I don't think she even understood the question. But when the Soviet Union was falling apart in the early 1990s, President George H.W. Bush unilaterally reduced our arsenal. And later on, the Soviets followed. And so it can be done. President Obama got the Nobel Peace Prize, but he didn't really do anything about reducing our nuclear arsenal. In some senses, it's easier in our country for a Republican president to do it because they're not considered soft on defense somehow, although that's a whole nother conversation. But we could easily reduce our arsenal. When I give a talk, I say, if you think nuclear weapons are a deterrence to an attack, how many would you have to put onto the capital city of your enemy to deter them from attacking us? And usually the answer is one. And so I said, yeah, so maybe we need two in case the first one doesn't work. So a couple hundred is more than enough. Why do we need thousands? And so it doesn't make sense. Really need some enlightened leadership to do this. And I was hoping President Biden would do that. He was known to say in the past that we should reduce our arsenal, but the uh, they just did a new review of our nuclear policy. It hasn't been released yet, but as I understand it, it doesn't really include any reduction of our nuclear arsenal or stopping the modernization.
So when you say we can't use these weapons, what is it that you mean there? Is it simply that we have so many or that the US has so many nuclear weapons that using all of them would destroy life on Earth?
Yeah, people think of deterrence as mutual assured destruction. So if you attack me, I'm going to attack you. So that's why you have to not do it. Well, Brian Toon and I wrote a paper called Self Assured Destruction. What if one country, the US or Russia, attacked the other and the other one didn't do anything back? Everybody in the country that did the attacking would die from starvation because of the climate response. So it would be like you're acting like a suicide bomber. For deterrence to work, you have to believe people are willing to kill themselves. It's completely crazy, and people just ignore that when they talk about deterrence.
So nuclear winter changes the logic of nuclear deterrence.
Yes, and nuclear deterrence also means that for it to work, it has to work perfectly forever. What if there's a mistake? What if uh, there's an accidental use of nuclear weapons? So, as we talk, President Putin threatened to put his nuclear weapons on high alert when soon after the Ukrainian invasion, which wasn't going his way. There was no evidence that anything changed actually in Russia. It was just words. But it really shocked people that somebody might consider using nuclear weapons. So, what if one nuclear weapon was actually used? What would happen then? Would the rest of the world recoil in horror and not do anything? Or would some uh, battlefield commander somewhere decide that, well, we've got to reply in kind? There's certainly the danger of escalation, and it could result in a global nuclear war. So I hope that our warnings about nuclear winter, which started in the 1980s, have permeated people's knowledge enough so that people are worried about that, and that's sort of maybe serving as something of a deterrence. In the 1980s, an American team, Turko Tun Ackerman, Pollock, and Sagan, and a Russian team, Alexander von Stenchikov, both calculate what will be the climate response to a nuclear war, and both of them got nuclear winter. I did a paper the next year uh, reinforcing that, and this information was given to both Presidents Reagan and Gorbachev. And because it came from scientists on both sides, they trusted it, and both of them said, we're ending our arms race because we're worried about nuclear winter. The nuclear war cannot be won and must never be fought. They agreed on that statement a couple years later. And so it really felt powerful to actually have science inform policy. There were also mass anti-nuclear demonstrations in democratic countries like the UK and the US that helped. So right now, the number of weapons started to go down. The arms race went away, but still there are thousands and thousands of nuclear weapons in the arsenals of the US and Russia. The problem isn't solved. Even today's arsenals can produce nuclear winter.
I'm thinking that many people will die from the direct effects of dropped nuclear weapons, and many people will die from the agricultural collapse. But could there also be further effects? Say that there's an agricultural collapse, and this destabilizes the world or decreases international cooperation. Do you foresee what we could call second order effects from nuclear winter?
Well, that's really not my area of expertise, but I can. uh, We, we've analyzed how much food there would be available in each country based on how the climate would change and how each crop would respond to the cold temperatures, less sunlight, less water. And our default scenario involves no more trade in agriculture. Each country would start hoarding what they have. In our country 2 years ago, there was no toilet paper to be found. People were hoarding toilet paper. So there, uh, this year, when India uh, stopped exporting their wheat because of drought, and they didn't have enough, and so there are in 2010 there was a drought and heat wave in Russia. They stopped exporting wheat, and the price of food doubled in the Middle East, and that was part of a trigger for the Arab Spring. And so we already have examples of hoarding, of stopping trade when people have shortages. And so, in such a dire situation, most of the world would have no direct effects of nuclear war. They'd just see maybe the sky getting darker, but there wouldn't be any bombs dropped on them. But they would all go to the library and read our articles and understand that they're going to have trouble growing food next year, and so they would keep what they have. And which do you want to do? Make a little bit more money selling it, or have enough food to eat? And so that was our default scenario, that there would be no international trade. The compli- the complications of that, whether there would be even within a country, would certain groups get a lot more food than other groups? That requires further analysis, and so we need to get other people who are experts in that to work on that.
Of course, it's a simplifying assumption that there would be no international trade in
Yeah.
food, but there is some justification for thinking that there would at least be a steep decline in international trade, because politicians, political leaders in each country is directly responsible for the voters of that country, and so you could easily see how food shortages around the world would have a kind of a nationalizing, inward-looking effect on uh, nation states.
Yeah, even in countries that don't have voters,
Yeah,
even even in dictatorships.
even in dictatorships, political leaders are in some sense responsible to the population. They can be overthrown. They can be harmed if the population becomes too unhappy.
Yeah, famine has resulted in a number of revolutions.
Diplomacy and international cooperation is notoriously tricky and difficult to make work. So I'm interested in exploring options for what could be done uh, if it goes wrong. So, kind of thinking about what we could do to prepare for a nuclear winter if it happens.
I think that's a terrible idea. If you think we can prepare for a nuclear winter, that increases the probability of it happening. I think people are afraid now that the use of nuclear weapons could expand into a global nuclear war, and it would be a catastrophe for everybody on the planet. And that's what the will of the people, that's what the ban treaty says and is worried about. If you think you can survive it, if you're going to have enough potatoes and fungus you grow on trees in the dark, and other distribution mechanisms, then why worry about it? Then I think that reduces the pressure not to have a nuclear war.
I'm saying we should do both. I think it would be prudent to both attempt to do everything we can diplomatically and politically to prevent nuclear winter from happening, but also prepare in the event of a disaster.
The global average amount of food stored is about 2 months' supply. So it's really grow it and then eat it, to transport it and eat it. So uh, to store enough food for years, for because a nuclear winter, the climate response would be about 5, 6, 7 years of cooling, and then gradually it would warm up. And so you need years worth of agricultural production you'd have to be prepared for. And
Okay, let's talk about, or touch upon at least, geoengineering, which is another research interest of yours.
yeah,
So normally when we talk about geoengineering, or at least how I think of it, is as a last resort against climate change, where you begin, or when you try to block out sunlight from reaching the surface of the Earth, for example, by creating artificial clouds. Um, Could we do sort of reverse geoengineering aimed at increasing sunlight on the surface of the Earth in the case of a nuclear winter?
I've heard of a couple papers have been written to try and quickly warm up Earth, but that's not the way that they have suggested. Uh, if there's a big volcanic eruption, it would cause a huge amount of cooling. I mean, there have been super volcanic eruptions that cause several degrees of cooling for several years. So the idea is to develop these short-lived greenhouse gases that absorb heat leaving Earth and radiate it downward and cause warming. But they would, CO2 has a lifetime of decades, and so you don't want to release more carbon dioxide. But in theory, you could design gases which are super absorbers, but only have a lifetime of a year or two. And you could stockpile them in tanks around the world. It doesn't much matter where they are because they would get distributed by the winds. And if you get this massive cooling, you could just release them and they would absorb heat and warm it back up at the same time scale that the smoke or the volcanic particles would dissipate. They would uh, come apart at the same time. So that's a theory, a theoretical study. Such gases don't exist, but in theory, perhaps you could invent them. But then it would be trillions of dollars to manufacture them and to store them and to keep them from leaking and keep it ready for a disaster that might never happen. And so, again, I think that's probably if you think that that would work, and then you have to worry about nuclear winter. I think that would be a terrible idea because it would increase the probability of people using nuclear weapons.
I definitely take your point that this could happen, but I think we can be very worried about nuclear winter while simultaneously attempting to prepare for it in the worst case.
No,
Um,
the way to get rid of nuclear winter is to get rid of nuclear weapons. And it's very simple. There's only a few thousand nuclear weapons in the world. It's a much simpler problem to solve than global warming because it's not the fundamental basis of our energy supply. It's not retrofitting everybody to drive an electric car and windmills and stuff. It's not changing a huge infrastructure. It's just turning off things. And so during the 1980s, there were like 70,000 nuclear weapons in the world, and now there's only about 13,000. So where did all those weapons go? We know how to take them apart. We know how to dilute the radioactive part. We know how to actually use it as fuel for nuclear power reactors. We know how to do that. It's very easy to do, and so it's not doesn't require any new technology to get rid of them and to dismantle them.
I think you're right that it would be more, or it would be easier to tackle than tackling climate change. Um, yeah. Okay. Let's talk about your experience working on nuclear winter throughout the decades. You've Nuclear winter as a theory has faced a lot of skepticism. How has it been dealing with the skepticism?
In the So 1982, I think I went to an American Geophysical Union meeting, and I saw there was a paper talk going to be given, the climatic effects of nuclear war. And I thought, that's curious. Wonder what that's about. And I went to the talk, and it was canceled because the people that were going to give it were some of them worked for NASA Ames Research Lab, and the director of the lab said, "You can't work on nuclear war. If NASA headquarters sees us working on nuclear war, it will hurt our funding." And so they said, all right, what are we going to call this? And they ended up with the term nuclear winter, which was uh, brilliant because it was the cause and effect in two words, and it's caught on. But that alerted me to what the idea was, and there was a meeting in Washington D.C. at the Shoreham Hotel the next year, just before the TAPS paper was released, and they was one of the first international satellite telecons. So there was a group in Moscow and a group in Washington participate at the same time, and the Russians and the Americans presented their results. And I said, I've been working on volcanic eruptions. I can use the climate model I'm using to look at the effects of smoke from nuclear war. And I wrote a paper that was published in Nature the next year. and was part of the team that was warning the world about nuclear winter. And then, as I mentioned, Gorbachev and Reagan ended the arms race and credited nuclear winter research as one of the reasons they did that. So
How did that moment feel to you, by the way?
it felt wonderful. What do I do? What do you do with the rest of your life now that you've solved the problem of nuclear weapons? uh, and but as you mentioned, there was skepticism. Some people said, "Well, these models are very simple. I don't believe them." And then there was some scientists who, like Steve Schneider, who did some calculations and found with a more sophisticated model that climate change wasn't as large, and called it nuclear fall, even though he knew that would be misinterpreted. But at the time, it was kind of easy to predict the result of the science was from scientists based on what their politics were. The conservative ones said it's not true, and the more liberal ones said it is true. And so a lot of people did calculations, and I did studies of forest fire smoke to see how it cooled the earth, and none of the work uh, said that nuclear winter was wrong. The fundamental physics is very simple. If you block out sunlight, it gets colder. And I mentioned analogs before. We have other analogs like the seasons. It's colder in winter because there's less sunlight. The days are shorter and the sun's at a lower angle. It's colder at night because there's no sun. So we have these fundamental analogs. We know that, and the fundamental question is how much smoke and how long does it last. At the time, the computers that were available were like these supercomputers, like a Cray supercomputer. But my iPhone is orders of magnitude more powerful than those. It has more storage and faster computation. So, uh, but still, nuclear winter. There was a National Academy of Sciences study by the U.S. National Academy that went over all the studies and said yes, nuclear winter is a valid theory, and that sort of put it to rest. And then, as I said, 15, 17 years ago, we started working on this again, and we calculated the effects of a war between India and Pakistan using a modern computer model that runs on uh, a standard computer now, not even a supercomputer. And we had enough computing power to do simulations not for 20 days like was done back then, but for 10 years. And we put smoke in. We also had a model that would have the smoke be heated, lofted into the stratosphere, blown around the world, and fall out years later. And so we did that calculation and we found, yes, nuclear winter, we still get nuclear winter in the center of continents. And so uh, we went back and did the nuclear winter, the US Russia case, as well as the India Pakistan case. Uh, then 5 years ago, thanks to a conversation I had with a program manager at the Open Philanthropy Project, we were able to get funded to continue this work. We were sort of doing it on the side without much funding, but we have substantial funding. We've done a lot of work in the last 5 years with a team with Brian Toon at University of Colorado and me leading it, and we've had other scientists working with us. And we've used the state-of-the-art computer model from the National Center for Atmospheric Research and redid the nuclear winter simulation for US Russia. And we got almost exactly the same result as we got from the NASA model from 15 years ago, which was lower resolution, had less physics in it. So that's pretty sure. If you put smoke in the atmosphere, we're pretty sure what the climate response would be. The fundamental question is still how much smoke. Another question people ask is, well, so we've tested nuclear weapons many times in the atmosphere before testing stopped. Why was there no nuclear winter? Well, the tests were done in the desert or out over the ocean where there was nothing to burn. So it's the smoke from the fires that causes the climate change, not the bomb itself.
The people or the scientists who ran these nuclear tests, were they aware of were they consciously trying to prevent smoke from being caused by these nuclear explosions, or could they have kind of accidentally set off a nuclear winter?
Well, I I think that they did tests where they trying not to kill people and trying to be in remote areas. Unfortunately, some of the tests in the Pacific produced so much radioactivity that the cloud drifted over islands where there were people and caused terrible death and radioactive damage in Bikini Atoll, for example, and Japanese fishing boats. And so, but that wasn't intentional. They were trying to keep it away from where people. That's why the first test of the plutonium bomb in Alamogordo in New Mexico and White Sands was out in the middle of a desert where there was nobody around. So it wasn't that they were trying to prevent smoke; they were trying to not do it where there was anything to be destroyed.
You mentioned that at some point you had problem getting funding for this research, which is, in a sense, quite shocking. Here you have a plausible causal mechanism that could harm billions of people, and you still are unable to get the right amount of funding for it. Do you think that humanity as a whole is just doomed to not focus on the right issues?
Yes, in the 1980s, I was able to get some funding for 2 years from the Defense Nuclear Agency, which is now called DETRA. They I think they figured that, this is a theory from a bunch of left-wing college professors. If we throw enough money at it, we'll find the flaw in it. But the more work we did, the stronger their theory got, the more sure we were that it was true, and then they stopped funding us. So we didn't give them the answer they wanted. We reported the science that we found. I've been funded by National Science Foundation for many years to study the effects of volcanic eruptions on climate, and I study them as an analog to nuclear winter. And so I sort of did a little of this on the side, but we really didn't have enough money. And it was actually the Open Philanthropy called me for some advice on funding a geoengineering project. And after I talked to the program manager, Claire Zabel, I said, "Would you consider funding work on nuclear winter?" We've asked the National Science Foundation, we've asked the Defense Department, who has the bombs, we've asked the Department of Energy that makes the bombs, we've asked the Department of Homeland Security, whose job it is to protect us from nuclear weapons. We've even asked the Intelligence Service, "Can you give us some funding to study this?" And we couldn't find a program manager that would fund it. Homeland Security said, "Well, if you want to study a terrorist dropping a bomb in New York City and where the radioactivity would go, we would fund that." The military said, "Well, we'll fund you to study climate change. Did you know that every naval base is at sea level? And so sea level rise is a problem. We want to study that or ice melting, but no, we won't fund it." We couldn't find a program manager. She said, "Well, okay, send us a I'm not sure what that is. Send me a proposal." So Brian Toon and I sat down and we said, "What would we do?" We'd calculate the how much smoke there would be, would burn cities for the first time, model that, would calculate climate response, would try and include the agricultural response, and we had a rather audacious budget. We thought of $1 million for 3 years, and we sent that to her, and she said, "Well, okay, send us a bigger proposal. We'll send it out for review, and if you need more money, ask for more money. We want you to be sure you have enough to get it done." So most program managers say, "Can you cut the budget?" But so we put in $2.98 million in this budget, and in six different pieces. And we said, "If you want to fund any of these, it would be great." And within a couple of months, they said, "Okay, here's your $3 million." That was the only time I ever had experience like that, to give you more money than you asked for in a much shorter period of time. And we were very productive. And 3 years later, we asked for renewal. We got another $3 million, and so $1 million a year. So we're funding groups at Colorado and Rutgers and Columbia University.
I can ask, what are we hoping to find out with this increased level of funding?
Still need to know exactly what happens when a city burns. We have high resolution models of forest fires and forest fire propagation, but we need to know what the fuel is in every city. And so how much material is there to burn? And does it matter if more modern buildings are made more of stone uh, or of steel rather than of wood, or is it the contents that burn? It's really the contents that burn. The fires last for hours, not the building itself burns. So we're working on that. We have a team working on that. And we need to work on what happens to if agriculture is reduced, how would society respond in terms of uh, economics, in terms of trade within a country and between countries? How would this availability of food change over time in detail? So we need a lot more work on that.
There's a sociological or economic research aspect to this problem also.
Yes. We wrote one paper on the economics with an economist at Rutgers, but it just sort of scratched the surface. So uh, the problem with economics is that uh, human behavior is a lot more complicated than the climate system. We have equations that describe how the climate system works. We have conservation of energy, conservation of momentum, and we can calculate how the climate will change. There's chaos, of course, built in, so you can't do weather forecasting beyond a couple weeks, but we can do multiple runs with different initial conditions and get a statistical representation of the climate. And we test these models every day by doing weather forecasts, and we do climate model simulations of past climate change. We know what causes were, we know what happened. We can model volcanic eruptions, we can model forest fires. So we're pretty confident in that. But human behavior and groups of humans are really complicated. I mean, who would have predicted the war in Ukraine having huge, massive changes to the world food supply, for example? How do you predict uh, human behavior and how people would behave, and so that's more difficult, but we do need them to work on that as best they can.
Alan, thank you for talking with me. It's been very interesting.
Thanks very much, and I hope publicity about this will help people to realize how dangerous nuclear weapons are.